Our next lesson is called Solving Equations Using Radicals. So for examples 1 through 4, we're going to find all the values of x that make the equations true. So keep in mind that our goal is still to get x alone. It's just that as we're trying to do that, we're going to have to deal with the fact that our x may be squared. Okay, so we're going to go through all of these different examples together. So we'll start with number 1. Number 1 is 2x squared plus 10 equals 42. So to start isolating my variable, I'm going to begin by getting rid of the 10 by subtracting 10 from both sides. That leaves me with 2x squared equals 32. Now I'm closer, but x squared still has a coefficient of 2. So we need to make sure we get rid of that 2 by doing the opposite of multiplying, which is to divide. So we're going to divide each side by 2. This gives me x squared equals 16. Now I do not want x squared. I want to know the value of x. So to undo squaring something, I must take the square root. So if I'm going to take the square root of this side to get x alone, whatever I do to one side, I have to do to the other to keep the equation in balance. And so then we end up with x equals, and the important part about this is we have a positive or a negative 4. 4 times 4 equals 16, but so does negative 4 times negative 4. So we have to account for that by doing this plus or minus symbol in front of the 4. Okay, let's look at number 2 underneath. Number 2 says x squared plus 4x equals 4 times x plus 16. So think back to what we've learned about solving equations when x was not squared. You must simplify your equation as much as possible before you start solving. So I would consider doing distributive property here on this side as part of my simplifying. So I end up with x squared plus 4x equals 4 times x is 4x, 4 times 16 is 64. So now it's as simplified as it's going to get, and I need to start solving. And I hope you notice that we have a variables on both sides type of situation. So we have this 4x here and this 4x here. So we're going to get rid of one of the variables. It doesn't matter which side you think of. They do end up being the same. So you're going to do negative 4x and negative 4x. You're going to subtract 4x from both sides to undo the plus 4x on the x squared plus 4x side. So you get x squared, these are gone, equals, these are gone, 64. So just like in number 1, if x is being squared, we want to do the opposite thing to undo it. So the opposite of squaring is taking the square root. So we're going to take the square root of this side and do the same thing on the other side so that we're keeping it equal and in balance. So we end up with x equals, and we get 8, but remember, 8 times 8 is 64, and so is negative 8 times negative 8. So we want to do that plus minus in front to show that both of those responses are correct. Okay, let's move up here to number 3. In number 3, it says 3x squared plus 2x equals 2 times x plus 36. So just as we had before, we have a distributive property that we must simplify. So we have 3x squared plus 2x equals 2 times x is 2x, and 2 times 36 is 72. Now we have variables on both sides, and I'm trying to get the x squared alone. So I'm going to get rid of the 2x that is on the same side by doing the opposite and subtracting 2x. Whatever I do to one side, I must do to the other to keep it in balance as an equation. So I get 3x squared, gone, equals 72. Now I can't take the square root yet because we're not allowed to do that, remember, until x squared is completely alone. Right now it's 3x squared, or in other words, it's being multiplied by 3. So the opposite of that, to undo it, the inverse operation, would be to divide by 3. Whatever we do to one side, we must do to the other. So we end up with x squared equals 24. In order to undo x squared, we take the square root, and you're going to notice for the first time, we don't have a perfect square. What we do have, though, is a radical that can be simplified, which we've learned about in a previous lesson. So we're going to go over to the side here, and we're going to take the square root of 24, and we are going to simplify it. So remember, we're going to find the largest perfect square factor of 24, so that would be 4, and then we're going to multiply it by whatever other factor we need. So in this case, it would be 6. You can either split them up and do that extra step, or just say to yourself, can I take the square root of 4? The answer is yes, 4 is a perfect square. So the square root of 4 is 2, that comes out from underneath the radical. Can I take the square root of 6 nicely? Is that a perfect square? No, so we keep it underneath. So that means we have x equals plus or minus still the 2 square root 6 answer. Okay, so that's important. You still keep the plus or minus even though it was a radical that we were simplifying. It's still true that 2 square root 6 times 2 square root 6 will give you that result, but so will negative 2 square root 6 and negative 2 square root 6. Okay, moving on to number 4. Okay, we have 1/3 x in parentheses plus squared plus 5x equals 5x plus 4. So it is important here that you understand the 1/3 and the x both need to be squared. So we're talking 1/3 times 1/3, which is 1/9, and also x times x, which is x squared. So we end up with 1/9 x squared plus 5x equals 5x plus 4. So just like before, we need to get the x squared alone. So in order to do that, we're going to have to get rid of whatever's on the same side as the x squared, which would be 5x. So to do that, we would subtract 5x from both sides. So we end up with 1/9 x squared equals 4. Now we don't want 1/9 x squared. We just want x squared so that we can eventually take the square root. So we're going to have to get rid of the 1/9. Now I could divide by 1/9, but we want to get away from dividing a fraction by another fraction. We want to make sure we use our reciprocal. So the reciprocal of 1/9 would be 9/1. I'm going to multiply by the reciprocal, and then I'm going to do the same thing on the other side. So on this side, they cancel out, and I get x squared equals, and then on this side, 4 is really over a 1, so you're really doing 4 times 9, which is 36. Now that x squared is alone, we can take the square root, and we would get x equals plus or minus 6. All right, in number 5, it says, how would you verify the solution to number 4? So we want to make sure we discuss what it means to verify. Verify is another word for check to see that the solution is correct. So how would you verify the solution to number 4? You would check it, okay? So we'll try to fit it in this space here. We would take 1/3 x squared plus 5x equals 5x plus 4. You're always going to write the original. Your next step is to substitute in. So you just have to make sure here, and we'll just kind of make quick little notes. You need to plug in 6, and you would need to do a check for -6. So at this time in the video, if you want to pause and try to check these, you can go ahead and do that. You can also practice that when you do your homework assignment for this topic, okay? But in general, you would write the original as you see that I have there, and if we have a positive and a negative result, we need to check both of those numbers. It's important. Now, how do you know if it's right once you do that? Well, it must check with both. And we'll say with both values. So if you solve it and one answer checks and the other one does not, then we have an issue, okay? So at this time, I want you to try out the last problem. It's a little bit of a challenge problem. See how you do. It says a square has a side length of 3x and an area of 324 inches squared. What is the value of x? So please pause the video and try this problem on your own. And when you're ready, you can resume the video to check your answer. Okay, so we have a square. It's already drawn for you. And if it's a square, if 3x is there, then it's also here. Okay? And it said area. So the big thing I want you to write down, even if you did this problem already somewhere, is that area implies we need you to multiply. So it's just another way of asking you to multiply. So they said that the area is 324 inches squared, and we want to know the value of x. So first of all, to find the value of the area of a square, you're really doing side times side or side squared. We, however, were given the area. So in A's place, I'm going to write 324. On the other side, I'm going to put in what our side length is, which according to our diagram is 3x. Now make sure when you do that, substitution, like always, should have parentheses around it. If you're putting 3x in S's place, always use parentheses, and then the squared will be on the outside. If you do not use parentheses, it's not the same value. The way you see I have written it, the squared belongs to the 3 and the x. If I were to write it like this, and you do not need to write this down, or you can if it helps you, if I was to write it down like this, that squared only belongs with the x. So we do not want that. We want parentheses around the 3x. So this would be 324 equals, and remember, if this is my 3x as a base, that means the 3 is getting squared and the x is getting squared. So this should be 9x squared. I need to get x squared alone, so I would divide both sides by 9, and I would end up with 36 equals x squared. To get x alone, I would take the square root. So normally I would say x equals plus or minus 6, but this is a problem about area and side length. So it doesn't make sense to say plus or minus 6. So we're going to say 6, and we're going to go back to the question and make sure we're answering it. They want to know what is the value of x. It looks like I can stop. I already know x's value. However, I will add my units. If area was inches squared, then my x value should be 6 inches. Okay? And that concludes your lesson on solving radical equations.